Hello, welcome to the video. In this lesson, we're going to be looking at section 3.1, where we're going to be solving quadratic equations. So anytime that we are talking about solving a quadratic equation, we are trying to find, or we're trying to solve for the x-intercepts of our parabola. So like got our graph, it looks something like this. And then you have a parabola that could potentially look like that. So we have a parabola that looks, something like this, and these points and these points here are representations of your x-intercepts, and that's how you would solve the quadratic equation, by identifying what those points are. So I think I said this in the Algebra 1 textbook. There is essentially three main ways to solve equations uh, using standard form, which is y equals ax squared plus bx plus c. The first one that they have here is using square roots. There are some stipulations that you have when you're solving using square roots. The thing is if you're using the standard form ax squared plus bx plus c, b has to equal 0. So you're using the equation essentially y equals ax squared plus c. When you are factoring, you can have values for a, b, and c, but the stipulation there is you have to have uh, certain terms that are factorable. Okay. Remember from previous lessons, you can always use the quadratic formula if need be, which I believe we talk about in a future lesson in this chapter. But so for as of right now, using these two. All right, when you're talking about graphing, your graphing is you're trying to identify those five main things that we've talked about in previous sections. Like, okay, what is the y-intercept? What is the axis of symmetry? What is the vertex? And then what is the x-intercepts? Can you find them by solving it using, any one of these methods? All right, so here they want you to solve it by graphing. The thing is with graphing, it is difficult to get an accurate representation of it. So we can graph it, sure, but really the only way that you can get an idea of being able to solve the equation is by uh, doing it algebraically. So when you're asked about solving it here, I'm just going to use either like factoring or square roots um, as it seems fit. Anytime you're trying to solve an equation, you have to make sure when it's a quadratic, so which means there's an x squared in one of the terms, you have to set your equation equal to 0. All right. If it is already, great. If it's not, you have to manipulate it in a way. So here for part A, x squared minus x minus 6 set equal to 0. It's already equal to 0, so I'm going to attempt to factor this. So I got parentheses, parentheses, set equal to 0. I got x here and x here. Minus 6 tells me the signs are different. So one's plus, one's minus. The minus x tells me the larger number in the set of parentheses is going to be minus. Are there two values that give me a product of 6, but their difference is 1, 3, and 2. Finally, once you factored it, you get to implement the zero product property. Zero product property means that you're just going to take x plus 2, set it equal to 0, and x minus 3 set it equal to 0 and solve each individual equation. This is now x equals -2, and this is x equals +3. That is how you'd solve it. If you were to ask what are the x-intercepts, this would be like -2 comma 0, and this would be 3 comma 0. For part B, it's not set equal to 0, so I'm going to subtract 4x from both sides. So now I got -2x squared minus 4x minus 2 is set equal to 0. I rewrote it that way in standard form to keep things consistent. All right, so since it's an equation and we have a complex trinomial with a negative number, first off, I prefer to solve things where my lead coefficient is positive. So, but we also have an advantage here that every single term, -2, -4, -2, they're all divisible by 2, but I'm going to divide everything by a -2 because at the end of this problem, I'm going to get a positive lead coefficient. So -2 divided by -2 is +1, so I got x squared. This is now going to be plus 2x, and this is going to be +1, and this is going to be set equal to 0. So now I can attempt to factor this. Parentheses, parentheses equal to 0. I got x here, same sign, plus. So when the second sign is plus, it means the signs are the same. What is that same sign? Refer to the first sign. Two values give me a product of 1. Sum is 2, 1 and 1. Since they're the same, I only have to solve for one of them. Zero product property tells me that x is going to equal a -1. Anytime you just have a one solution, usually that means that your x-intercept is also your vertex. So like in this particular one, because it started off with negative, I'll just assume that was an upside down U shape. So -1 being right here, it would look something kind of like this. And then it would cross at -2 because of the value of C. Okay. Here they want you to solve the equation using square roots. Uh, we can because there is no x, x value for a and b. So I can simply add 31 to both sides. Now I got 4x squared is equal to 49 plus 31, which is 80. Divide that by 4, so x squared equals 20. Take the square root of 20. I'm just going to round it. So x is going to be equal to, and since I took the square root of this, we're going to be looking at both the positive and negative value of the square root of 20, which is about 4.47. So we have two x-intercepts. One is positive 4.47 comma 0, and the other one's negative 4.47 comma 0. So here if I subtracted 9 to both sides, now I got 3x squared is equal to -9. X squared is equal to, divide that by 3, it would be -3 if I take the square root here. Now, I can't take the square root of a negative number. If you type that in, you'd get some kind of error code on your calculator. This is a situation where it's no solution. Now over here with part C, here's how you'd go about solving this one. First off, our square is a series of terms inside the parentheses. So what you're going to do is you're going to try to isolate that. So I'm going to multiply this by the reciprocal, which is 5/2. So this gets canceled. So now I got x plus 3 quantity squared is equal to what, 25 over 2. Now, in order to solve using square roots, you're just going to take the square root of this here. So the square root of x plus 3 quantity squared is just going to be x plus 3. 25 over 2, if I took the square root of that, I would get plus or minus about 3.54. So now, because I have extra stuff on the left-hand side with x, what I'm going to do is I need to separate this into two separate equations. This is going to be x plus 3 equals positive 3.54, and x plus 3 is equal to negative 3.54, and solve those individually. So if I subtract 3 here, x is going to be equal to 0.54, positive. Over here, if I subtracted 3 to both sides, I think I'd get negative 6.54. So still two x-intercepts. Um, it's just not a nice clean value, which is you're not always going to get um, for particular graphs. So kind of using this uh, in these previous examples, but this is just the definition for using zero product property. Again, using zero product property is going to assist you in being able to find your x-intercepts when factoring. So, and then here, if you're going to factor, again, you got to set your equation equal to 0. So subtract 45. So now I got x squared minus 4x minus 45 is set equal to 0. So attempt to factor, I got x here and x here. Different signs because of the minus 45. It's the large number is going to be subtraction. So two values that give me a product of 45, but their difference is 4 is going to be 9 and 5. Zero product property tells me that x is going to equal a negative 5 and x is going to equal positive 9. All right, finally here it says find the zeros. Find the zeros of the function. Anytime they say find the zeros of the function and they give you a function, or even if they give you a y equals portion of it, what you're going to do is you are going to replace f of x or y with 0. So this now turns into 0 equals 2x squared minus 11x plus 12. And then you would solve it however you seem fit. All right, I'm going to attempt to factor this. So this is going to be 0 equals parentheses, parentheses. I have 2x and x because it's a prime number. So now this is a complex trinomial. So we have to kind of change some things. It's still going to be the same sign, and they're going to be minus because you refer to this first sign of what the sign is. So because it's a complex trinomial, now I have to figure out that the product of these two values plus the product of these two values is going to have to give me 11. So, but the product of these two has to give me 12. So if I did 4, let's see if I go 4 right here and I go 3 right here, 3 times 4 is 12, but 2 times 4 is 8 and 3 times 1 is 3. If I added those together, I would get 11. So that makes sense. And then you could always double check by foiling out your factor to see if you came up to the original equation. Zero product property, so it's going to be 2x minus 3 set equal to 0 and x minus 4 set equal to 0. Add 3 divided by 2, x equals positive 3 halves, x equals positive 4. And that is being able to solve quadratic equations. Hope this helps. Till next time.